we're going to start with the inputs. These are most of them. The other ones are up here. We'll get to those in a minute. That's our instances coming in, but they're a little different. So what we're going to do is just start with the curves. Now, at the moment, to get a curve into, well, I'm talking about the Maya curves here. So at the moment, to get a curve into our system, we would need to create a curve. So if I just make another one here, turn the corner, so that's just a Maya curve. You can absolutely go and see its verts, see what it looks like. You can use all of the Maya tools on it. So you can, rebuild it. You can change anything you like. But to get that into the Bifrost system, we'll have to take the curve, middle click and drag it in, and then hook it up to our array. So once it's hooked up to the array, you can see that the poles have immediately snapped to it, because our which curve is set to higher than the original array was. So there's 0, 1, 2, 3, and now 4. If I stay at 5, as I explained going through, any numbers higher than the amount of curves in the array is just going to default to the last curve in the array. I think I like 2. 2's good. That's, it works really well. You bring it in, you hook it up, and everything just works. That's what a tool should do. The problem here is that we can't expect artists, as in our users, to do that. They may not know Bifrost very well. Some of them, of course, will and be fine with it. What we're doing is not going to preclude that. What we need to do is set up a more Maya-based way to do it. So to do that, I'm going to add an input. Now, when you're at the base level of Bifrost, and you can see here, pole tool shape, this is not a compound. There is no other compound above this. So when you're at the base level of Bifrost, when you make an input, that's an input from Maya. How do we get to those? Well, we get to those in the node editor. So what I'm going to do is I'm going to clear my node editor like that. And I'm going to just add my Bifrost in here. I don't need the transform right now. So let's look at the inputs and output connections of this. This is what's coming into our Bifrost graph. So this is the Bifrost graph shape. You can find it by going to Outliner, turning on shapes. That's it there. That's what's selected. And these are all of the inputs to that shape. And you can see the inputs coming in because we've dragged them in. So let's just organize that really quickly. We'll get all of the curves into one side. We'll get the 2 instances up the top here. And all of our attachment points, which I explained just before, will pop down here. And let's have a look at how those are going in. So the curves are going in separately, 1, 2, 3, 4, or 0, 1, 2, 3. And these are the inputs for them here. You can see that the attachment points are a little different. There's 4 attachment points, but only 1 input, because the attachment points are an array. You can see that by looking down here. This is an array coming in. This is a single object coming in. You can tell, as we said in week 1, you can tell because it's wearing a hat. So you've got 4 separate curves coming in and an array of attachment points. What the best thing to do in this case is to turn our curve input into an array input, and let me show you why. But anybody who's done any work with Maya will know about the node editor and will know about connecting things in the node editor. That's kind of like a basic skill for a Maya tech artist. I'm pretty sure that you guys learned it yourself during the course. Maya has this thing called a node editor. It's how you make connections. And Maya, like most DCCs, just about all DCCs really, is essentially under the hood just a big bunch of data that's connected to other data and doing data type things. And this is what this represents. So when we want to get stuff into our Bifrost graph, we want to do it in such a way that it's easy for a tech artist to set it up, and it's easy as possible for a user to get things in. So rather than having to drag and drop each curve they make into here, what we can do is set up an array on the input, which is our curves array. So let's do that. So the very first thing I'm going to do is I'm just going to make a value. And this is not at all important. This is just a dummy value that I'm going to use to create my input. I could just right click here, So I could drag this off here and plug it into something. It would create an input, but I want to do it this way. In my value type, I'm going to go to object, because a curve, which will become a strand, and my curve is an object in Bifrost. I'm going to go to object and array. Now I can check to see that value has taken the right type. Array object, that's correct. I can delete this. And now we have an input called value. If I come across to my node editor and expand this, this is what you get here. You can hover in there to say what kind of value are you, and Maya considers this to be a generic value, which is fine. Let's rename it curve array input. You see it's jumped around a bit on the node editor because it likes to be alphabetized, and there it is there. If we open that up, you can see it's already added one input. And this is how we make this easy. We've got a curve array input. We tell everyone it's an array in the name, keep things sensible. I can now break the connections to the strands and everything's going to go away. Take our Maya curves here, and let's try and do this in some sort of semblance of order. So 1, 2, shape 2, shape 3. That'll be fine. You should also name me stuff, but I haven't for this one. And what we need to do is connect the relevant part of the shape node coming out here, which is world space 0, into the curve array input. You'll notice that if I hover that input over here, a lot of it grays out. That's Maya telling you that I can't put this. I can't put this type of data into that kind of port. So what it does leave is curve array input 1, and obviously the strands inputs that were already there. So if I put that in there, two things happen straight away. One, Maya gives you a color based on what's coming in, and it pops up another array for you. So there's a filled array entry and an empty array entry. And now we just keep going. So we plug that one into the second one, makes a new array entry. World space into the third one, makes a new array entry. And finally the last one. And most importantly, there's still a spare one, and that will continue further and further down as people add more curves. Now, right now, we're not doing anything because our graph is still expecting the inputs to come from these 4 strands. But I can fix that super easy by just taking this input and plugging it in there, and we get everything back that we wanted. So we'll set our which curve back to 0. That's that curve now. Obviously, the order that they come in is the order that the arrays are in. So that's something to keep an eye out for. And we no longer need those guys. Probably should keep the inputs box though. We don't need those. So now we've taken our, let's just bring those back for a second. There we go. So now we've taken the inputs that we did have, which were 4 separate curves that we went into Maya and we dragged and dropped in. We did all of that kind of thing. We've taken those, which is a slightly difficult way to do things, and made it a more Maya-centric way to do things, where we just have a single array. And you can see they're all coming into that array. That array leaves an empty slot at the end to add more curves to. By connecting through the node editor, we've just added extra functionality to our tool. Cool. So that's the first set of inputs. That's done. These guys, we don't need them anymore. So let's come back to Bifrost. We'll select those and we'll just delete them. We don't have any poles. That's okay, because we don't have any poles because our input curve array over here has nothing being input to it, which is causing errors down the line. First thing we probably should do is let's just change that port type to an array of objects. What that's going to do is stop the errors happening down the line. Now we can plug our curve array input into the input curve array. We get our poles back. And like I said before, the order that these are going in reflect the order that they are in Bifrost. And just to show you how easy this is now, I can take my new curve, I can drag that one across. Don't need the transform. I can just take the world space 0 and I can drop it into the empty port that it's given me. And now this is part of the array as well. And it's just as easy as, so now there'll be a 4 because it's added in last, 0, 1, 2, 3, 4. It's just as easy to take it away. Take that away. From there, set that to 3. That's connecting things in the node editor. And as such, we don't need to change our attachment points input. because our attachment points input is already an array. It's already doing everything we want it to do, and it's already easy for our users to add another one. If they, for example, wanted to have another pole, like a fiber optic cable hanging off this layer, this level of the pole, rather than up at the insulators there, they run another cable along the shaft of the pole there. All they need to do is add another attachment point to the base array, which is here, which is calculated on the base position of the instance, and the entire system would work as well, including, adding sag to those lines and all the randomizations and the culling and everything that we went through. So that's pretty much got our inputs sorted out for these two. The other inputs we have are our instances. So this is our instances input. Again, this is an array, and the way instancing works, like we did in week 2, is it takes an array anyway. It takes an array of geometries to instance on our points. All I did to make that work was drag that. That is an input node. You can tell by the icon here. All I did was drag that out to an input. Probably give it a better name. So right now they're called mesh. So we just call this instance input array. And already we've got something that's a lot more tool-based. You can't see anything yet. So if I come across to my channel box, you've got nothing in the pole tool shape here yet. You can go to the attribute editor, go to the extra attributes on the shape, and you can see everything coming in. There's our curve array inputs. There's our instance input array that we just set up. I don't know why that's there twice, but it is. And there's our attachment point array as well. So back to Bifrost. That's pretty much got our inputs covered. We have 3 sets of inputs to this graph. We have curves themselves, the attachment points, and the instances. Let's start making our controls, and let's talk about setting up our interface in Bifrost, our interface in Maya, and our interface with the next technical artist that comes along. And when I say interface, I mean, what are you going to leave them to work with? Because right now, this is possibly the best case of what you're going to get from someone. That all of the controls are named, and they're named in reasonably sensible ways. If you have any complaints, you can send a letter to Autodesk. No, I'm kidding. This is me. I built this. I rebuilt it for this lesson so that you could see what a good pass-off looks like. Number of wires tells you exactly what it is. And because it's sitting inside the cull wires compound, you can guess that this is the number of wires you want to keep. If I want it to be really good, and I would do this in a studio, but you can't have everything perfect. You can have it good, but not perfect, right? If I was trying to be perfect with this, I'd create a sticky note, and a lot of people will, and it's good that they do, don't get me wrong. And I would say, number of wires is the total output wires for final strand creation. So annotating. Annotating is a really good thing. It's good to do it. But even more important than annotating, because it might be 4:30 in the morning and this is the very last thing you do, and you might try and annotate and type everything in a language that makes sense to you at the time, but isn't actually a real language because you've been working for 22 hours. If you don't annotate, name. Always name. So these are the controls for the count. This is the rotations calculation. This is the random culling. This is a Bifrost node I didn't name. There's the instances input. This creates instances for each attachment, split into wires, wire strands, flatten the array. Even without the annotations, you can make some sense of this. So as we go forward and put our controls in, we're going to do a lot of the same things. And also, when you put in controls, you can see right now I have 1, 2, and 3 total inputs to the Bifrost graph. You can have as many inputs as you want, and what's really cool is you can move things around on the input. So I can take my curve array input and I can move that to attachment points, and that moves there. Nothing changes over here in the node editor. There is still an input called curve array input, and the fact that there are wires and poles in our screen means that it is still working. I can move it back. Just move to input. Okay, so this lets us organize our graphs really, really easily and quickly. And we'll start to do that now. Something you need to bear in mind is if I put in just a new input in here, I'm going to name this, so count control input, right? That's pretty specific. I probably won't go that far, but just as an example, and I plug in the number of instances to that. First thing that's going to happen, everything disappears because by default, that input is set to 0. And we can check that by going to out there. There's our new input and it comes through as 0. What we want is something like 12. You want to set that, and you want to set that before you publish this, and you want to set that before you send this anywhere. Giving someone a tool that doesn't show anything on screen is a really good way to get a reputation for making crap tools. You don't want to do it. Okay, so name everything. Make sure you test your own tool before you release it always. And if you're a junior, make sure you take it to the person that is your boss and say, hey, could you quickly look over this and tell me what you think? Because you can absolutely be too close to your own work. You can absolutely think that this makes total sense to you, but when it gets to an artist who looks at it and goes, which curve? Which curve what? There are a million curves in here. There's the curves that make these, there are the curves that make that, there are this sort of thing. Artists don't know how this works. That's something you need to remember from the very beginning, is that what artists are really good at is art. They're not good at technical things as a rule. Some of them are, and they end up becoming tech artists like you. Mostly what artists are good at, what they're valued for, is what they can do with your software. The beautiful, beautiful things they produce. Your job is to help them produce it as quickly and as easily as possible. With that in mind, name everything well. Don't assume your artists won't come into your Bifrost and pull everything apart, because they will. Don't assume that they won't go in there and put in some ridiculous number like 450,000, because they will. They tend to test everything to get the look they want. There is nothing wrong with that. That is absolutely what they should be doing to get the most beautiful result they possibly can. But you need to think about that, and you need to realize really, really quickly and really strongly, you don't know what people are going to do with this. Things that seem absolutely ridiculous to you will be done to this probably within the first 5 minutes of it being released. Safeguard against them. It's why we put in a non-zero clause into our number of instances, for example, so that when somebody puts -4 into an instancing count, it's going to default to 3, not -4. How do you have -4 instances? Doesn't make artists stupid, far from it. It makes them experimental, and it's exactly what we want them to do. We just need to realize that they're going to try to do impossible things. We should just gently stop them from doing it. Otherwise, the tool's going to break and everything goes to hell. We all miss deadlines. Everyone loses their job and the world ends in fire. Okay? No pressure there. Moving along. So now we have an input, and we have an input. More importantly, we have an input in Maya. There it is. Does it work? Sure. 6 poles. 34 poles, 8 poles, 28 poles, -2 poles, -16 poles. You see how that's just shot straight back to 3? We can increase that in Maya quite happily. The tool works. Something else you need to know right now, and I don't know a way around it without learning how to code for the attribute editor, which I kind of used to know how to do, but don't quite anymore. The order in which you add these are the order they're going to turn up in the attribute editor. It's up to you if you want to go and investigate how things are added to the attribute editor, learn the API around that, code for it, absolutely fine. If you don't, you need to know that piece of information, that the first control that's going to turn up on our new tool in the attribute editor is number of instances. Probably a good one to be first, because it controls the main thing, how many poles. And remember, we're just connecting Bifrost up to Maya. So I'm going to connect these in an order that I find to be sensible. You can rearrange them inside Bifrost. That order is not reflected in Maya. Number of instances and curve to instanceable. Those are my first two. My first two and my most important. Curve to instance on snaps back to 0. I can snap that around quite happily. Okay, that gives your layout department choice. And of course, because this is connected to Maya, I can absolutely grab that curve and keep on editing it. happily as I want to. That is part of the tool set. That is part of the functionality of our tool. Let's just keep going and adding controls. This is actually fairly easy. The hardest thing about adding these controls is deciding which order you want them to come in on. Let's make sure we've got our stuff selected. Let's delete that empty transform that we don't need. And we'll go to our layer editor. Number of instances and curve to instance on. They're super important. I'm happy with those being the first thing. In fact, we can get rid of our node editor for now. Get our Bifrost graph back. So what should we add next? Well, what I want to do is group things. So I want the culling to be in one input. I want the data input, like rotation, to be in its own input as well. And then the sag and the random to be in their own input. By that logic, what we'll do now is we'll actually do the data. So you've got how many instances, so how many poles, and curve to instance on, which curve you're on. Those are the two most important. Now we start controlling how artists can make this look. So we've already got a little bit of that with number of instances, yeah? Number of instances controls how many things are on that curve. That's already a look. That's if you've got a shot that's set up somewhat like this, then that's already a look control. So is curve. So let's get our data in. Rather than just adding to that, I'm going to make myself a new input. And we're going to call that rotations input. Rotation. Random rotation, leave the seed for now because the seed is going to be controlled elsewhere. Once more, we're going to work on the names. It's okay to call everything an instance because you can tell the artists what you mean and they will get used to it. An instance is the thing that you're putting on the curve. That is the instance. It is the pole. What our tool does is it puts down those instances on the curve and then draws wires between them. So that makes this logical. Call it random instance rotation. And once more, we're going to go out and check layer editor. You see how these are split out to X, Y, and Z? This is a Maya thing. This, if I went to the attribute editor, which, you know, they're also, let's just close some of this up. The extra inputs are already showing up. On the attribute editor, they look like vectors, X, Y, and Z, X, Y, and Z. And we can test that by taking this guy and just setting it to 30. Does everything rotate 30 degrees? Looks like it. How about we just start changing this? Yeah, that works too. So we can maybe set this to 15 and everything leans back and forwards randomly. Cool. The reason we're not doing the seeds for these randoms right now is because we do not want to give our users, I think there are 7 distinct seeds in this Bifrost graph. We don't want to do that. We want to give them one master seed to work on. All right, let's jump back to Bifrost. We'll select our pole tool again. We'll jump back to Bifrost. I'm happy with that for my rotations input. People will read that and go, yep, I kind of know what that is. That's great. Let's make the culling now. So I'm going to make an input for culling as an input. We'll call it the culling input. And unless you're going to go into the attribute editor later, put these into groups and things, I'm not going to do that. I'm just going to do all of that with naming. So just like everything in here has the word instance in it, everything in here is going to have the word cull in it. So number of wires becomes, well, this is a difficult one because we're putting down the number of wires left. So wires after culling might be better, might be clumsy. Sounds pretty clumsy to me, but it does follow everything that we've been talking about. So I'm just gonna leave it there for now. That's our first culling input. Then we want to do the random culling input. So random cull minimum, you guessed it, random cull maximum. These can be renamed. It's just the order that you need to worry about. So let's go back because every time we put something new in there, it resets to 0. Number of wires to 0. Wires after culling, 0 wires. We need to go back into there and just test as we go. It's faster to test as you go than it is to test at the end. And that's because you at the end, you've added all of these different things, right? As you go, you know what you just added. So our rotations are happy. Wires after culling, let's put that back to 4. That's working beautifully. Let's check our random cull. So if I take my minimum up, it goes up pretty fast in Maya, but it is working. So let's just edit that, 0.05, 0.15. Yep, we lost our pole here, which is what those two values tend to give me, which is good, so because I can check things. That's working. Awesome. moving on, we have one more cull here, which is cull by pole. This needs to be explained on the input as something like wire culling chance per pole. Yeah, it's long. Yeah, but it's descriptive. So if I just pull that up, you can see that again, Maya goes up really quickly. If I hold down control, it doesn't go up so fast. You can see the wires disappearing per pole, which is nice. That's exactly what we wanted. So that's our culling done. Or is it? Is there anywhere else we need to cull? Let's check. So we're culling here per pole. That's just making a random per wire. So that's random sag per wire. I must remember that for later. We don't have any inputs up here. So yeah, I'm going to call that done. This guy just wants a seed. Remember what this is calculating is a random amount per attachment. Okay. So it's making an array, a random array of size 4, because we've got, well, it might be 4. At the moment it's 4. If we go ahead and change our wires after culling to 3, then that array, that size is going to be 3. We just want a seed for this because the offset doesn't change. We're going to come back to that one. So that leaves us with the sag controls. And we'll put them in their own input as well. So if we input, as we've been doing, and we'll name it for ourselves and the next tech artist to come along, which also might be you in a year and a half. Trust me, you don't remember everything you do, especially when you're doing a lot. Call this the sag input. Now, let's talk about what we want to go in first here. Probably what's important to go in here first is the sag controls, because that, again, that's a visual control for a. So the very first thing I'm going to put in here is sag, and I'm going to call it wire sag. I don't need to give it any more than that. I could say wire sag amount, but immediately people start looking at this and playing with it, they're going to get it. This is a very visual one. So as soon as you enter a number into wire sag, you immediately see what it is. And it tells you what it is. And let's get our wires after culling back up to 4. That's the default we want to set. We'll just leave it there. The other thing we're doing as we're going through is testing and setting our defaults. So that's wire sag up and running. Pretty self-explanatory, which is a good way to start this. Keep it as simple as you can. So I think the next thing we need to put in is sag per pole minimum and sag per pole maximum, because poles are greater than wires. In the perceived hierarchy, the artists are going to want to change the poles first, then wire per wire. Okay, so let's put this in here and this in here. Everything's going to change a bit because it goes to 0, as I explained. And we'll just call this pretty simply sag per pole minimum and sag per pole maximum. And so at this point, you might be wondering why I didn't just make a single random value for these. The answer is because I wanted to show you guys different ways of setting up a random input. You can have minimum and maximum value, which chooses a random value between the minimum and maximum. That's cool. Everybody understands that. You understand that. I understand that. It's all good. You can then have a hidden min-max, which is where you have a single value. Then Bifrost will take the negative version of that value and the positive version of that value, or the negative version of half of that value and the positive version of half of that value as a spread, or whatever you want, and choose randomly from there. Or you can have a percentage, which is just comparing it to a random number generator and deleting anything that is less than what the random number generator comes back with in between 0 and 1. I wanted to showcase all of those and show you guys that there are different ways of doing it. Okay, so that's the reason for that. Let's go to our channel box, and we've now got sag per pole minimum, sag per pole maximum. These have to be something. 1 is good, because that's a random number between 1 and 1. And if you remember the internals, that is multiplied by the result of those two. So I could say minimum 0.8, gives you a bit of refinement, maximum 1.25. Play around with it till you get a nice default that you want to give to your users. I'm okay with 0.8, 1.25. That's pretty nice. We'll go back to Bifrost. We'll hook up the other two. So that one and that one. And again, you get some changes because the result of this is being multiplied inside of here. I'll rename this sag per wire minimum, sag per wire maximum. Very sensible. says exactly what it is on the box. And we can come in and just, give this a bit as well. Or whatever you think looks good. I'm okay with that. I'm aiming to get a pretty generic look right now. I mean, if we want no randoms, we can just do that. We'd have to make those two the same as well. There we go. In fact, you could probably zero that. No. Well, yes, you can. Because you can then just adjust the sag. So not only am I testing that these work, I'm testing that you can use different combinations of them to get what you want. So if you only want a tiny little bit of random, you're able to do that. You're able to get that for a subtle look, or you can go quite hefty with it. And also our numbers work in the negative, which is quite nice as well. So testing, super important. Keep testing. Let's just set these to say 0.5 to start with so they've got something. We're building a nice generic default for people to look at that immediately shows them the system is working when they start the tool, which is this. It's great. It's working. Back to Bifrost. So those are the inputs there. Lastly, oh no, we've done that. So that is our inputs complete. We've now taken all of the Bifrost inputs. Now I can't actually go in here and change these anymore without going to Maya, which is exactly what I wanted to do. That's complete now. We have our inputs. Our tool is starting to take shape. Let's go across to the channel box. Here are our, except for the job Matsport, here are all our new controls. These will be all of the controls we need to control this. Now, there are other features I could add to this that I haven't added in this example. For example, there's a way to insert new poles based on a locator and a distance from the existing poles. I've done that before as well. So that's if you wanted to give your users a bit more of a hands-on ability to edit things and to move things around. You can also force move the point. So you can have a locator on each point, and you can have the ability to move the poles around as well as having them instanced. That might be a good thing for you to try out on your own time to get better at this. But, I've only got 2 hours to give you a lesson on this. So this is what it is. This is the basic version, the stripped down version. So what we need to go on to now, let's just jump back to Bifrost, is that we've got a great tool, but it's still in Bifrost. Like it doesn't have an output. Its output is only a terminal, so we can see what's going on.